Hey everybody, 7.5a, rational exponents and radicals. Ideally, you have learned this lesson possibly live, maybe not. Um, but our objective here is to rewrite expressions that involve radicals or rational exponents, and rational exponents would pretty much be fractional exponents or decimal that you can turn into a fraction. So first things first is all of this, all right? We have this, what we typically call the square root sign. It's actually the radical sign. The number up here is called the index. That's in the crook of it. Next page will have all this information for you. And then the number underneath the radical sign is called the radicand. Funny new names, I know, but so be it. All right, so let me move myself down to here. All right, so the number under that radical sign, as I just said, in this case it's A, is called the radicand. All right, just some new vocabulary. N, the number N, I know it sounds weird, it's a letter, but the number N in the crook is called the index. Now, what the index does is it gives us the degree of the root. Kind of new information again. The degree means how many numbers multiplied together that are the same give me my radicand. All right, and I'll do a lot of examples and explain this with context. But typically, a square root has a degree of 2. So if I want to find the square root of 49, I could put the radical sign 49 as my radicand, and then a little 2 here. But we don't ever put a 2 there. All right, but there technically is a 2 there for a square root. If we're doing a cube root, it has a degree of 3. All right, so just to be clear on what that means, if I want to find the square root of 49, oh boy, that's ugly. That is just going to be 7 because 7 times 7 gives me 49. There's a little 2 up here that's invisible. All right, but if I want to say, let's do the cube root of, let's say, 8, that means what three numbers multiply together to give me 8 that are the same. So there's no real algorithm. That would just, you have to kind of go through the guess and check method or use your number sense to figure out that it's 2 times 2, which gives me 4, times another 2, which gives me 8. Okay, so that's what the index means here. Okay, so let's take a look-see. What is the index of the above radical and what is the radicand? Good. Hopefully you got, for the index, it's going to be this 4, and the radicand is the 81. All right. If you wanted to figure out what it actually is, you could figure out what times what times what times what gives you 81. 4 times. It's 3. All right. So now this is some powerful information here. Okay. It sounds weird again with the examples I show. Hopefully you maybe see them now, but it might be a little clearer. If the nth root of A is a real number, which they all will be for now, and M and N are positive integers, then this first thing will be true. This is another way to rewrite a radical. All right. If I have A to the 1/nth power, meaning there's an exponent that is a fraction with a numerator of 1, the denominator of the fractional exponent is the index. Okay. What also will be true is if that numerator is not 1, if I have A to the mn, again, the same thing occurs. My index is my denominator. But now what happens? My numerator of the fractional exponent becomes the exponent of the entire radicand, the entire piece. All right. So technically, if I revert back to here, this 1, I could put it to the first power here, and it doesn't change it. So it's the same rule for the first one as for the second one, but we don't really ever need an exponent of 1. Okay. So again, if we have a number to the exponent of a fraction, the numerator of that fraction is going to be the overall exponent, and then the denominator of that fraction will be the index of the radicand. Okay, so let's do some examples here. All right. Here I have, what is A to the 4/5 in radical form. So right now, this is an exponential because it has an exponent, okay? What would it be in radical form? All right, Paul, I'm not going to make you answer this, but think about it. All right. It would be A would be my radicand. The 5, since it's my denominator, would be my index. So it would be the fifth root of A to the fourth power. All right. We could also, didn't want that tool. It could also be written as the fifth root of A to the fourth power, the whole thing. It doesn't, they're equal. They're equivalent. Okay. I just wanted you to see, I could just put the exponent on that A, or I could put it on the whole thing. All right. And what this means is if I do A to the fourth power and then take the fifth root of it, that would be the same thing as A to the 4/5 power. See, this rational exponent looks a lot simpler, but we have to understand what it means in exponential form. All right, you're going to try this one now. This one's a little, it's a little curveball at you. So if you get it wrong, no biggie. Let me hide it now. What is 12A to the 2/3 in radical form? All right. Did you notice the only thing, this goes back to the beginning lessons of this chapter, the only base that has the exponent is A. All right. This 12 technically has an exponent of 1. So this 12 is going to be on the outside. All right. That 12 is not going to be any part of that radicand. It's not getting square rooted, cube rooted, any rooted. All right. Only the A is. So that's why only the A is underneath that radical sign, A squared. All right. With an index of 3. So the way we would say this would be 12 times the cube root of A squared. All right. And again, don't just rush through this and say, I don't get it. I don't understand it. Let's take a pause. Okay. I know this video might be a little bit lengthier because there's a lot of information. The denominator of my fractional exponent is my root. My numerator is just the exponent next to it. Okay. Let's reverse our thinking here. What if I give you this this radical form, and I want it in exponential form? What do you think we do here? Well, my radicand is B, so that would be my base. Okay, I'll give you that start. Now, what would the exponent be for this one? Hope you said 3/5. All right. The 5 is the index, which is the denominator of my fraction, and the exponent on that B is the numerator, which is 3. So B to the 3/5 is the same thing as the fifth root of B cubed. All right, try these 3. Pause, try these 3 on your own, see if you get them. Fingers crossed. Okay, any questions, as always, reach out to me. All right, what about this one? This is where I want to kind of like go a little bit more in depth. I want to simplify, kind of want to figure out what the numbers are. Okay, I want to do the cube root of 27d to the 5th. Now, I'm going to give you a hint in a second, but think about this. What has the exponent of 5 in this radicand? All right, so here's a little shortcut. I could do the base 27 to the 1/3, and then d to the 5th to the 1/3. That would be changing into exponential form, but I'm not done here. Can I do anything to 27 to the 1/3? Meaning, are there 3 numbers that multiply together to give me 27 that are the same? Well, let's start with 1. 1 times 1 times 1. No. 2 times 2 times 2. Well, we already said that was 8 earlier. 3 times 3 times 3. Well, 3 times 3 is 9. Yeah. So this 27 to the 1/3 becomes 3. And d to the 5th to the 1/3, here we're going to use the power rule. And really all this is going to become, I'm sorry what I'm doing here. It's going to become d to the 5/3 because I'm going to multiply 1/3 times 5. And when I multiply straight across. So my final answer will be 3d to the 5/3. This is my whole answer. And please note that only the d has that exponent. Okay. All right. Here it is, everything. We're taking stuff we've learned previously. Simplify in radical form, okay? So note, sometimes it wants exponential, sometimes it wants radical, meaning my answer should have something like that in there, all right? First thing I want to do is remember, I can rearrange this all I want. I'm going to take this 3 and this 8. Since they don't have any exponents, I'm going to put them off to the side and make that 24 because everything here is multiplying together. All right, so this 3 and this 8 make that 24. Okay, so now what I have left is x to the 1/3 times x squared. X to the 1/3 times x squared. These are the same bases. This goes back to one of the very first lessons we learned in chapter 7. What do we do to exponents? Don't worry about what they look like. What do we do to exponents when we're multiplying the same bases? Hopefully you said add. All right. Hopefully you said add. So my final answer is going to be 24x. Well, now what is 2 plus a third? That's 2 and 1/3, right? Yeah. But little side note, little teaching part. We don't want to have mixed numbers. We want to turn that into a fraction. It used to be called an improper fraction. That vocabulary doesn't exist anymore. This would just become 7/3. So my final answer would be 24x to the 7/3. This is simplified radical form. No, it's not, is it? Why not? This is exponential form. So what I have to do now is change it yet again. I have to put this 24 out in front because it does not part of a rational exponent. This part is my x is my base, which the base becomes the radicand. The numerator becomes the exponent on the radicand, and the denominator becomes the index in the crook. All fancy words, I know. This is the final answer in radical form. Or is it? No, it is this time for real. All right. Like I said, I know that was lengthy. It is new. I want to make sure you understand it. You can try this IXL for practice, and then you're master.